Okay, so now we have another type of word problem. Jenny buys 15 boxes each containing 625 toothpicks. She arranges 6 toothpicks at a time into a tetrahedra until there are not enough toothpicks to make any more full tetrahedras. How many toothpicks does Jenny have left? And there's a nice picture of a tetrahedron, which is like a pyramid with all equal sides. And, this problem seems a little weird, but it's actually fairly simple in how to approach it, and it's an excellent example of a nice way we can use our multiplication properties to simplify so much of our work. So, 15 boxes of 625 toothpicks. We group them 6 toothpicks at a time. The on a tetrahedron stuff doesn't even matter really. You can even like one way I used to solve problems in school was to just get rid of whatever nonsense was in there so that I could just work with what the problem's telling me. And now we can read the problem as, all right, 15 boxes of 625 toothpicks. She arranges 6 toothpicks at a time. So we have groups of 6 toothpicks, which means like whenever we divide things into groups, you are dividing that number, right? So we're dividing the total number of toothpicks by 6. And the remainder is how many toothpicks are going to be left over. How many toothpicks remain afterward. So, this is just a modular problem. Of course it is, because that's the lesson we're on. But it's a modular problem in disguise, since we're dividing by 6. Now, our instinct might be to do, alright, I want to find the total number of toothpicks. That'd be 5 times 625. Right? That might be like our first instinct on what to do. Especially like if we're coming from a class like Algebra 1, where, you do things in sort of the traditional way. And you would find out that that number would be 625 times 15 is like 9,375. And then what I would do is, all right, I need to find 9,375 mod 6. And you could divide that out, sure. But no, we're not going to do that. Because we're just going to use the fact that it's the product of 15 and 625. And that's going to be by mod 6. And to even make it simpler, I can just find the mods of 15 mod 6, which is just 3. Because 6 times 2 is 12, add 3 to get 15. So that becomes 3 times, now 625 mod 6. Well, I know that 6 times 100 is 600. And 6 times 4 is 24. So 6 times 204 is 624. And the remaining value would be a 1. So that what this really amounts to is 3 times 1 mod 6, which is just 3 mod 6. So what that means is that we have 3 tooth picks left over. And we have turned a potentially complicated problem with messy division with a number like 9,375 into a relatively simple and easy to work with problem, which is the core of all modular arithmetic, simplifying all the work we could possibly be doing.